Okay, now we'll discuss on Kirchhoff's laws. Kirchhoff's laws are two fundamental principles used in electrical engineering to analyze complex circuits that cannot be simplified using only series and parallel resistance rules. It was formalized by a German physicist, Gustav Kirchhoff, in 1845. These laws are based on conservation of energy and charge. Okay, there are two laws. One is called Kirchhoff's current law, and a short form KCL, and another form is called Kirchhoff's voltage law, KVL. Okay, we will look at these laws separately because this is very important in circuit analysis. The Kirchhoff's current law is also known as the junction rule. So there should be a junction to apply the Kirchhoff's current law. KCL states that the total current entering the junction must be equal to total current leaving it, reflecting the conservation of charge. Okay, so we can consider this is a junction where there are certain number of current is entering. This arrow shows current entering the junction, and this is outward arrow showing the leaving currents. Okay, this shows that the current which is entering I1 plus I2 plus I3, which has the inward arrows, should be equal to I4 plus I5 plus I6. Okay, this can be represented in using the summation sign. Summation of I input would be equal to summation of I output. Okay, this also can be represented as summation of all the I is equal to 1, IN should be equal to 0. So if we sum all the current in the junction, we always get a 0 at the junction. Okay, let's try to implement this one using this circuit. We have a power supply of 5 volt, then we have a 5 ohm here, 10 ohm here, and a 100 ohm here. Okay, we can look at this. What is the current entering? We have two junctions here, I1 and I2. Therefore, the current entering from here should be equal to the leaving two. If you add these two, you should get here. Another, we have one more junction which is I2 and I3 is flowing. So which means that the current leaving from this junction is going to the junction. This is the current is entering the junction, and it is leaving as a two currents, I2 and I3. Okay, let's try to verify this one in LTspice. Okay, we just put a voltage source here, and we need a few resistors also. I put a resistor 1, resistor 2, resistor 3 here, and we also need a ground for that one. The ground is put in here, and we'll wire this one. So from this, we have to put all the connections. Okay, put the ground. Since we want to measure the input junction current, we also put some resistors, because through the resistor only we can measure the current. So I also put some 2 resistors in the entering junctions. Okay, then I also wire these connections. Okay, if the connection is not favorable, you can cut it and rewire it. Okay, I put the wire here. Try to make all the connections properly. Okay, our connections are over. Then we need to put the value. Right click on the voltage source. I will give a 5 volt. Okay, the resistor, first value I put a value 5 ohm. Then here also I put a 5 ohm for simplicity. Here also we put 5 ohm. Then we can try another value for here, 10 ohm. Then here also we'll put a 100 ohm resistor. Okay, then the circuit is completed. We try to make a simulation, transient simulation with a 0.1 stop time. Okay, you also put it like this, and we try to run this. Okay, showing the simulations. So first thing I can check it the current flowing through this resistor. So this we have two junctions, junction 1 and junction 2. In the junction 1, the current is entering this from here, and it is leaving here and here. Okay, there are 3 currents here. So first we find the current here. So this is coming as about 575 milliampere. The minus sign may come because it is showing the directions in this direction. So if we are considering opposite direction, you can take the minus sign to plus and then take the reading. Okay, so this is minus 575, and from our analysis, it should, these current through these two resistors should be equal to this 575. So we will measure the resistor in R1 and current in the R1, which should be equal to minus 400 milliampere, and this should be about 200. So if you add these two, you will get 600. There is a problem in sign because it is you can see that this is showing the this direction, and here this is showing the opposite direction. That's why the problem is coming. Okay, actually when our analysis, the current should leave the junction like this, isn't it? That's why we get a minus sign, but actually it's matching. Okay, so now the current through passing through here is about minus 150 milliampere. Then it is leaving to the junction, and it is divided into two through the resistor R2 and R3. So minus 150 entering, and it is dividing to one current is should be equal to about it's again coming as about between 120 milliampere and 150 milliampere. Then see what about here. This is coming as about less than 30. So if you add these two things, you will surely get to this value. That's why the two junctions we have varied the Kirchhoff's current law.